Hi everyone, welcome to this linear algebra bootcamp for quantitative finance. In this whole bootcamp, what I'll teach you is, of course, the basics of linear algebra. So, if in case you have never studied linear algebra or don't even know what is linear algebra, don't worry. I'll teach everything from very scratch and we'll go deep dive into, the complex stuff. Also, at the end of this bootcamp, I have lined up certain quantitative finance projects so that you can actually understand what is the application of linear algebra in the quant finance space. So I'll walk you through the table of content what we will see in this whole bootcamp, and then I'll show you certain projects which we will dive deep into in the end of the bootcamp. Don't worry, you don't have to know the projects right now because, as I said, I'll be teaching each and every element in this bootcamp. So first, I'll walk you through what is the course of content. So first of all, like how I've structured this linear algebra bootcamp is we'll see, what are the vector spaces. We'll deep dive into vector spaces, subspaces, linear combinations of and systems of linear equations, linear dependencies. Then, we'll jump into the matrices. There are certain functions that we perform on matrices such as linear transformation. Then we'll see how can we represent. We'll see matrix representation of linear transformation. We'll see bunch of elementary operations like addition, subtraction, multiplication, transpose, inverse, and then we'll see how can we solve systems of linear equations. We'll deep dive into the determinants, how to calculate determinants of a matrix, calculate the eigenvalue, eigenvector, and then what we'll do is we'll deep dive into the quant projects, which the first project that we'll do is the PCA, which is the principal component analysis of the yield curve, and the second project that we'll work on is mean variance portfolio optimization. It's totally fine if you have not heard even a single stuff, because as I said, this bootcamp starts from absolute basic. So I'll be teaching each and every component of it. Also, at the same time, I want to showcase. Okay, so let me share the projects that we'll be working on. So okay, so okay, I hope you can see my Excel spreadsheet. So, because as I said, linear algebra, will be using in the quant finance space. So we'll be working on certain projects. So we'll see how to build this efficient frontier. Okay, we'll see how to, this is basically some stock prices that we have: JP Morgan stock, Goldman stock, Morgan Stanley, and we'll see how to calculate certain risk metrics and how to optimize our portfolio. Okay, and the last project that we'll work on is, of course, the Black Litterman portfolio optimization model. It's a heavy model which is also used in the industry. But do not worry if you have not heard anything on this, because as I said, I'll teach you everything from scratch. One last thing which I wanted to share is will be the book that we will use is this. Just give me 1 second. Let me share the book. Okay. So I hope you can see my screen. So the book that we'll be using in the course of this bootcamp is this Linear Algebra and its Application by Gilbert Strang. This is one of the most famous book which is used by most of the universities when they teach linear algebra to engineers in India, or let's say if you are in United States, all the STEM courses they teach this linear algebra, and its application. This is the most common book referred by most of the institutions. So, what I have done is I'll be following this book in this boot camp so that, we have a structured learning. So, of course, you can, I found this book online. So, I got this PDF online. So, you can also search for this PDF. But eventually, what I'll do is I'll teach you each chapter bit by bit, and we'll try to cover the concepts of linear algebra and see how can we apply that in the field of quantitative finance. But, before that, this is all complex stuff. Let's understand the basic stuff. Let me start sharing my screen and let me teach you from the very basic. First, what is quantitative finance? And second, how can we use it? Okay. Okay. So first of all, as I said, welcome to the Linear Algebra Bootcamp. First, let me tell you quantitative finance, right? Because eventually we'll use the application of linear algebra in quantitative finance. Okay, so someone asked which edition book do I have? It's a fourth edition book that I'm consuming. So let's first understand what is quantitative finance, you know, and then we'll jump to the linear algebra part of it. See, quantitative finance is actually a discipline which is made up of different pillars. Okay. To be honest, it is made up of five different pillars. So if you see, so quantitative finance as a discipline is made up of mathematics, statistics, and this is I'm this from this from this point our boot camps actually starts. Okay, so quant finance is a field which is made up of five different pillars: mathematics, statistics, economics, programming. Okay, and finance. So these are the five pillars of quantitative finance. So eventually this field, is basically made up of these five pillars. So, the very first part, the very basics of quant finance is knowing the mathematics, knowing the mathematics. So for understanding the mathematics, there are various subjects which you as a quant should learn. Okay. So the first subject is linear algebra. And this is where this bootcamp, I'll be teaching the linear algebra part and its application in quantitative finance. But I'm just giving you a overall understanding of, this whole space. So, in mathematics, what is required is linear algebra. Second subject which is required is calculus. Third subject is differential equation. The fourth subject is probability theory. And the last one is stochastic calculus. So we are at step one of it. Okay. We are at this part, linear algebra. Okay, so this is just to give you a brief of why this whole linear algebra aspect is important, because this comes into mathematics, and as I said, mathematics is one of the pillars of quantitative finance. But the question is, what is linear algebra? Okay, I see Anna. Hi, could you please help brief the use of these topics in finance? Okay, I'll go one by one. So first, let's understand the use of linear algebra. Okay, first let's understand linear algebra in detail. Okay. So the first question is, what is linear algebra? Okay, I'll cover the applications part of it in few minutes. But the first question is, what is linear algebra? So linear algebra is a discipline of mathematics which deals with solving linear equations. Okay, so it is a discipline of mathematics which deals with solving linear equation. So apparently, your next question will be, what is a linear equation, right? What is a linear equation? Okay. So your next question would be, okay, I understand this field is used to solve linear equations, but what is linear equation and how is it used? What's the application part of it? So let's understand what is linear equation. Okay. So, think it, okay, I'll give you, a very simple analogy. So let's say let's say we have something. Okay, let's say when you add, you know, let's say when you add two numbers together. Okay, let's say when you add two numbers together. Okay, when you add two numbers together, the result must be 10. Okay, this is the first thing. Okay, second is, let me write the statement, and this will actually help you understand this in a greater detail. Okay, and the second statement is, when you double the first number, when you double the first number, when you double the first number and subtract the second number, okay, the result must be 3. Okay, so these are two statements. Okay, so can I write these two statements in this format? Can I write the first statement? Let's say my two numbers are, let's say my two numbers are x and y. Okay, let's say my two numbers are x and y. So what the first statement is saying is, when you add two numbers together, the result must be 10. So can I write x plus y is equal to 10? Please tell me, can I write this? Please tell me, can I write this? Feel free to write in the chat yes or no. Okay, perfect. Perfect. So, and the second statement, can I write when you double the first number? So, our first number is 2x, and subtract the second number. The result is 3. Can I write this? Please tell me. Can I write 2x minus y is equal to 3? So, these essentially are what? These are linear equations. These essentially are what? These are called linear equation. So, okay, you might be thinking, okay, now we understand what is a linear equation, but then why do we need linear algebra, right? Your question would be, why do we need linear algebra? So the reason is, we need linear algebra so as to solve linear equations. Basically, we'll use the methods of linear algebra to solve such equations. Okay? To solve such equations. So I hope you understand what is linear algebra. Linear algebra is nothing but it is a field which is used to solve linear equations. Okay, what is linear equation? Equations like this. Equations like this are called linear equation. So what is our goal? Our goal is to, you know, our goal is to, so our goal is to find the values of, our goal is to find the values of x and y such that our goal is to find the values of x and y such that both the equation are true at the same time. Okay, such that both the equations are true at the same time. Okay, so what we are trying to do, we are trying to find the values of x and y. We are trying to find the values of x and y so that these two equation becomes true. Okay, I see someone asking, can someone find the book and post it? So, I would say you can basically find it on the net, and it's very, accessible from the net. You can just write Linear Algebra by Gilbert Strang, and you would be able to get this book. Okay. So I hope, did you understand this thing? Please tell me. Did you understand this thing? Please tell me. What is linear algebra? Are you able to understand? Basically, linear algebra is used to solve what? Linear equation. Okay, I see a very good question. What's linear about them? What's linear about them? So if you see, you know, why is it called linear equation? Why just not equation? That's a very good question. The answer to this is, the answer to this is, okay, let me write the equations. X plus y is equal to 10, okay, and 2x minus y is equal to 3. So why are these called equations and not why are these called linear equation and not just equations? See, the thing is, if you look at the power of x and y, if you look at the power of x and y, what are they? It is 1. If you look at the power of x and y, it is what? It is 1. See, this is essentially x raised to the power 1, right? Plus y raised to the power 1 is equal to 10. And similarly, 2x raised to the power 1 minus y is equal to 3. So if you see, the power is 1. That's why we say this as linear equation. If it was like something like this, x square plus 2x is equal to 10, or let's say, you know 2x square minus y square is equal to 5, then this is no longer linear. Okay, this is no longer linear. Why? Because if you look at the power has now become 2. Power has now become 2. Okay, power has now become what? 2. So always remember one thing. Always remember the power. Why we say this as a linear equation is because the power is 1. I hope that's a very good question. Okay. And please feel free to ask any such questions, even if it's the basics of it, or, even if you do not understand, please feel free to ask. So now the question is, okay, tell me one thing, because eventually, we are dealing with the real world, you know, we are dealing with real world. We are living in the real world, right? So do you think, let's say, let's say, let's say, what if, what if there are multiple equations like this? What if there are multiple equations like this? Let's say x plus y plus z is equal to 1, 3x plus 4y plus 5z is equal to 5, 4x plus y, or let's say 4x plus plus y plus z is equal to 18. Now we have, let's say, how many equations? We have 3 equations. But you know that in real world there can be multiple equations, right? Do you all agree or not? First tell me. In real world there can be multiple equations like this. Do you agree or not? Agree. Perfect. So now if in case there are multiple equations like this, we need something to solve it. Otherwise the whole system will become very complex. And that's where the use of linear algebra became very important. Okay, that's where the if by any chance, if by any chance, if you have studied physics, you know if you have studied physics in your grade 11th or grade 12th by any chance, we are told that there are multiple processes happening at the same time, right? Multiple processes happening at the same time. So sometimes to solve those processes, we need the help of linear algebra. So just for, just remember this thing. Why do we need linear algebra? In short, to solve linear equations, right? In short, why do we need linear algebra? To solve linear equation. And this is actually nothing but we are defining our processes. This is, we are defining our processes. Okay. So just imagine in this way, X, Y, Z are 3 processes. Okay. And those are dependent. And those are dependent. Okay. Those are dependent with each other. So that's why to solve these processes, we need what? We need linear algebra. Okay, I hope this is clear. Please tell me, is this clear? Why do we need a linear algebra? Okay, thank you so much. So now the question is, what are ways to solve linear algebra? Or what I can say is, what are the ways to solve linear equation? What are the ways to solve linear equation? Okay, so what I'll do is I'll write all the methods and then we'll study each method one by one. So the first method is substitution method. So the first method is substitution method. The second method is called elimination method. Third, we have something called graphical method. Fourth, we have something called the Gaussian elimination method. Fifth, we have something called the Gauss-Jordan elimination. Okay, method. And the last is inverse matrix method. Okay. So now tell me one thing. If in any case, let's say, if I pick this method versus this method, will it give me the same result? So the thing is, these methods are used to do what? To solve linear equations. Okay, this we understand. So let's say if I use this method and this method, will it give me the same results or will it give me different results? Please, same. That's right. It will give you the same results. So any method you use, it will eventually give you same results. Okay. Perfect. This is very good. Just wanted to tell you so that, you do not get scared of one method. You don't think, oh, there's so much to learn. See, eventually we'll do lot of examples. Okay. Mathematics is all about doing lot of examples. Okay. So let's understand the very first method, which is the substitution method. Okay. Let's understand this method first. Also, we'll learn something called matrix. We'll learn something called matrix. So these are called what? Matrix method. Okay. So what I'll do is I'll just point in black. These methods are called the matrix method. So you will get, okay, I see one question. So you will get you will get similar results if, in all the six methods. Okay. You use any method, you should get similar results. Okay. All right. So let's understand the very first method, which is called the substitution method. It's called the substitution method. And this is like very simple method. Believe me, this is one of the simplest method which you will come across. Okay, so let me give some example. Let's say, let's say we have two equations. Let's say we have two linear equations. 2x minus y. So let's say example 1. Okay. 2x minus y is equal to 0 minus x plus 2y is equal to 3. Okay. Now, these are the two linear equations. These are what? These are two linear equations. And let's try to solve it using the substitution method. Let's try to solve it using the substitution method. So if you see, as the name suggests, you know, as the name suggests, we need to perform we can say we need to substitute the value of one variable into the other. Okay. How many variables do we have? Can you tell me? How many variables do we have? Can you tell me? X and Y are two variables, right? X and Y are two variables. So let's try to understand how can we use this substitution method. So we have 2x minus y is equal to 0. So can I write 2x is equal to y, or can I write y is equal to 2x? Please tell me, can I write this? I have just shifted this on the right hand side. So y is equal to 2x, right? Now what I'll do is I'll substitute the value of y in the second equation. So this is basically first equation, this is equation first and this is second equation. Okay. So what I'll do is I will substitute the value of y is equal to 2x in the second equation. Okay. So what will happen? So if you see what is our equation, minus x plus 2y is equal to 3. So minus x plus 2y is equal to 3, right? And what is y? If you see what is y is equal to 2x. So can I write? So I'll substitute the value of y. What is y? It is 2x. So can I write minus x plus 4x is equal to 3 and 3x is equal to 3, and can I write x is equal to 1? Please tell me. Please tell me, can I write this? What I've done is I have substituted the value of y is equal to 2x in second equation. So this is actually my second equation, right? This is my second equation. So what I've done is I've just substituted the value of y. Okay. I've just substituted the value of y, which is what? 2x. Which is what? 2x, right? And then just solve the equation. So minus x plus 4x is what? 3x is equal to 3, and therefore x is equal to 1. Now what I will do is, once I have this value of x equal to 1, can I put this value in this equation? So again, so what I'll do is back substituting the value of x in equation first, right? So what was our equation first? Y is equal to 2x. So we know that what is x? X is 1. So can I write 1 here? So y will be what? 2. So what have we got? We have got x is equal to 1 and y is equal to 2 is basically solution of the linear equation. It is basically the solution of linear equation. And what is the linear equation if you remember? It is 2x. So this was our linear equation, 2x minus y is equal to 0 and minus x plus 2y is equal to 3. Now, a lot of times, of course, when you're solving it, see, these are simple equations. What if you have three variables in place, right? Right now, you just have x and y, which are two variables. So what is the way to understand if the solution that you have given, is it correct or not? So just to see, just to check if you are going on the right path, what you will do is you'll substitute these values into this equation and check if you are getting the similar results. Okay, so what I'll do is 2x minus y, it should give me what? 0, right? It should give me what? 0. So what is the value of x? It is 1. What is value of y? It is 2. So if you see 2 minus 2 is what? 0. So definitely what I'm getting here versus what I have here, these are matching. So it means, okay, it is, the solution is correct. Now let's verify for the second equation also. Minus x plus 2y is, okay, minus x plus 2y is equal to 3, right? So now if you see what is x, it is 1. So I'll write minus 1 plus 2 times what is y? It is 2. So eventually what will this give me? Minus 1 plus 4, which is 3, which is what we have here. So this basically means that these solutions are perfect. These solutions are correct. Okay, these solutions are what? Correct. These solutions are correct. So what we are doing in substitution, let me revisit the concept again. In the substitution method, we need to substitute the value of one variable into the other variable. Okay, into the other variable. So let's say this is our example. Okay, 2x minus y. Okay, this is our example. 2x minus y is equal to 0 and minus x plus 2y is equal to 3. So what will, this is our first equation, right? This is our first equation. So what we'll get from this equation? Y is equal to 2x. And this is our second equation, right? Minus x plus 2y is equal to 3. So what I'm doing is I'm substituting the value of y into this equation. Okay, I'm substituting the value of y into this equation. So what I'll get is x equal to 1. So now what we have gotten, x is equal to 1. Now I'll do what? Back substitute this into this, right? I'll back substitute this in here. So what I will get? Y is equal to 2x. I'll put the value of x as 1, which I'll get y is equal to 2. So eventually x is equal to 1 and y is equal to 2. Please tell me, did you all understand how did we solve this linear equation? Okay, perfect, perfect. Now what I'll do is, and did you all understand how to check if the equations that we have, that we have gotten, are they correct or not using by substituting the values into these equations? That's it. Okay. So now let's do one more example, which is, let's take three variables. Okay. Let's let's take a second example, which is x plus y plus z is equal to 6, y plus z is equal to 5, and z is equal to 2. So these are three equations. Okay, this is equation first, this is equation second, this is equation third. Let's try to solve it using the substitution method. Okay, so what I'll do is, can I substitute this value in here? Please tell me. Can I substitute equation 3 in equation 2? So substituting the value of z in equation 2. So what is our equation 2? Y plus z is equal to 5. Y plus 2 is equal to 5. So we have substituted our value here. So y is equal to 3. Okay. So we know that z is 2 already and y is 3. Now what we'll do is we'll substitute the values of y and z in equation first. Okay. Substitute the value of y and z in equation 1. Okay. So what is equation 1? X plus y plus z is equal to 6. X plus y plus z is equal to 6. Now what is my z? It is 2. So, and what is my y? It is 3. So y is 3, z is 2. So x plus 5 is equal to 6 and x will be 6 minus 5, which is 1. Okay. So x will be what? It will be 1. Okay. So now basically what is the solution? What is the solution of my linear equation? It will be x is equal to 1. It will be x is equal to 1, y is equal to 3, and z is equal to 2. This will be my solution of my linear equation. Is this clear? Please tell me, is this clear? Okay, perfect. So now what we'll do is, I hope is this method clear what we are doing? Is this method clear what we are doing? We are basically substituting it so as to get the values of our linear equation. Now let's understand elimination method. Let's understand the second method, which is what? Elimination method. So let's understand elimination method. Okay. So basically what I'll do is I'll take an example to showcase this. Okay. I'll take an example to showcase this, and we'll take the same example. Okay. We'll take the same example, which is 2x minus y is equal to 0 and minus x plus 2y is equal to 3. So if you remember this, the first example which we took, this one, 2x minus y is equal to, okay, sorry, 2x minus y is equal to 0 and minus x plus 2y is equal to 3. So let's use the same example for understanding the elimination method. So as the term says, eliminate. What is this method? Eliminate. Okay, eliminate. So what I'll do is, first, let's say this is my equation first. This is my second equation. Okay, this is my equation first. Okay, so I'm using. Okay, so I see two questions. If there are n variables, then we have n number of equations. Yes, that should be correct. If let's say, okay, so I see one question. If there are n variables, let's say, x, y, z, so there should be three equations. Okay. So what I can say is if there are n variables, there should be n equations. Okay. Okay, and then there is this second doubt. Please use the same example from substitution. Yeah, I'm using the same example. If you see, I'm using the same example. Okay, so 2x minus y is equal to 0, minus x plus 2y is equal to 3. So we'll use this example and tell me what is the results that we should get. We should get what? This, the value of x is 1 and y is 2. This is the final answer we should get for this using this elimination method. Okay, so what I'll do is, first thing is multiply the second equation by 2. Okay, so what I'll do is multiply the second equation by 2. So what it will give me? Minus 2x plus 4y is equal to 6. Correct? Please tell me, is this correct? Please tell me, is this correct? Will I get this? If I multiply my second equation with 2, will I get this or not? Please tell me. Yes? Okay. Now what I'll do is I'll add this to my first equation. I'll add this to my first equation. Now what is my first equation? First equation is 2x minus y. Okay, so what essentially I'm doing is I'm adding these two equations. Okay, basically this equation. Okay, I'm adding what? This equation and this equation. Okay, so what will I get? 2x minus y is equal to 0. 2x minus y plus minus x 2 plus 2y. This is on the left hand side, right? And on the right hand side, what will I get? On the right hand side, what will I get? 0 plus 6, right? 0 plus 6. Do you all agree? Do you all agree what I did? So what first thing is I'm multiplying the second equation by 2. So this will be my equation, right? Now what I'm doing is I'm adding this equation and this equation. That's it. So what is my first equation? 2x minus y. And what is my second equation? My bad. So my second equation is minus 2x plus 4y, right? Minus 2x plus 4y. And essentially what I need to add? 0 plus 6. Okay. So 0 plus 6. So 0. This is all for this equation and 6 is for this equation. First tell me, did you all understand this? Did you all understand what I did? Okay, so someone says no. Okay, Rahul says no. Okay, so Rahul, just understand one more time. Okay, what I'm doing is first equation I'm multiplying. Okay, my bad. Okay, let's say we have these two equations, right? Essentially, what we need to do is we need to eliminate. Okay, we need to eliminate. So what are we trying to do in this process is in this process, we are trying to cancel something. We can either cancel x's or we can either cancel y. Okay, this is what we are trying to cancel. So right now what I'm trying to cancel is, my x. Okay, how will I cancel my x? See, it is 2x and it is minus x. So of course, the first thing is to multiply this equation by 2, which we just did. So once we multiply this equation by 2, we'll get this. Now, if we want to eliminate x, it's simple, right? Because 2x minus y is 0, and here you have minus 2x plus 4y is 6. If you just think, if we just add these two, so 2x minus 2x, so x will get eliminated, right? So essentially what the aim is to eliminate x. The first aim is to eliminate x, okay? The first aim is to do what? Eliminate x. So here we have 2x, here we have minus x, okay? So now we have gotten this 2x minus y. So now if you see, can I cancel these out? 2x and minus 2x, can I cancel these out? And minus y plus 4y is what? 3y. And on the right hand side we have 6. So now y is equal to 2. So now we have gotten y is equal to 2, right? So what we can do now, we can just substitute the value of y in equation 1. We can just substitute the value of y in equation 1, right? What is our first equation? 2x minus y is equal to 0. So I can just substitute this value, 2x minus 2 is equal to 0, 2x is equal to 2, and x is equal to 1. So basically the value of x and y is what? 1 and 2. And this is the same result that we got using the substitution method. Is this clear to everyone? What did we do? So the aim of elimination method is to eliminate either x or y to get the other variable. If we are trying to eliminate x, we'll get the value of y. If we are eliminating y, we are getting the value of x. Okay, tell me one thing. Let's try to eliminate y here, instead of eliminating x. So let me write the equations. 2x minus y is equal to 0. Okay, and then we have minus x plus 2y is equal to 3. Now we need to, the goal is to eliminate y. Can you tell me how can we do this? Can you all tell me how can we do this? How can we eliminate y? So the first step is to multiply the first. So this is the first equation and this is the second equation, right? So multiply the first equation by what? 2. Multiply the first equation by 2. So we'll have, because we are trying to eliminate y. So we have 4x minus 2y is equal to 0, right? So this is my equation first, and let me write my second equation. Minus x plus 2y is equal to 3, right? This is my second equation. If I want to eliminate y, can I just say add equation 1 and 2? Add equation 1 and 2. So what will I get? 4x minus 2y plus minus x plus 2y is equal to 3. So if you see, minus 2y plus 2y gets cancelled out, right? So what is left is 4x minus x is equal to 3. This gives you what? 3x is equal to 3. This gives you what? X is equal to 1. So once we have x equal to 1, what we can do is we can put this in here, the value of x. So 2x minus, we know that substituting value of x in first equation, which was our original equation. 2x minus y is equal to 0. So let's put the value of x, which is 1, minus y is equal to 0. Can I write y is equal to 2? So essentially the value of x is 1 and y is 2, which is what we got in which method? In the substitution method. So in elimination method, we are trying to eliminate either x or y. Is this clear? Please tell me, is this clear? Okay. Please, if there's any doubt, please feel free to ask. If there's any doubt, please feel free to ask. Okay, I see a couple of yeses. So now let's take a difficult example. Okay, let's take a difficult example. As I said, mathematics is all about solving a lot of questions so that you have a good understanding of the concept. Okay, so what I'll do is I'll write three equations. X plus y plus z is equal to 6. X minus y plus z is equal to 2. 2x minus y, sorry, 2x plus y minus z is equal to 5. So x plus y plus z is equal to 6, x minus y plus z is equal to 2, and 2x plus y minus z is equal to 5. Now we need to solve this using elimination method. Now can you tell me what can we do? Can you tell me what can we do? Just think. Okay, so I see eliminate y first. Okay, some equation second and third. Okay, yeah, that's the right thing. Anyone else? There's one more way. You all are on the right path actually. What you are saying is correct only. So what I will do is, so you all are saying to do this, which is absolutely right. We have minus y plus z minus z. Okay, so this will actually cancel out. So but what I will do is, as I said, there are multiple ways to solve this. I'll first go, I'll eliminate z. So what I'll do is I'll first eliminate z. How can I do that? By subtracting, subtract 1 and first equation and second equation. So what will I get? X plus y plus z minus x minus y plus z is equal to 6 minus 2. Okay. So x plus y plus z minus x plus y minus z. So if you have if so what basically happens here is this minus gets multiplied. So if this value is plus, this will be minus. So minus minus is plus, and again minus plus is minus. Okay. So this is getting multiplied here. Okay. So this is equal to 4. Okay. Now what will get cancelled out? X and minus x will get cancelled out, right? Z and minus z will get cancelled out. So what will be left? 2y. 2y is equal to what? 4. So y is equal to 2. Okay. So first, so y is equal to what? 2. So here I have eliminated two things. I have eliminated x and I have eliminated z. Okay. So now what I will do is, I'll plug this y equal to 2 in my first equation. Okay, I'll plug this y is equal to 2 in my first equation, and I'll plug y equal to 2 in my third equation. So let's see what will we get. Okay, so step 2 is substitute, or let's say substitute y is equal to 2 in equation first. So what is my first equation? X plus y plus z is 6. So x plus y plus z is 6. And what is the value of y? 2. So x plus 2 plus z is equal to 6. X plus z is what? 4. Right? So this is my first equation. So this is what I have got. And what I'll do is, step 3 is substitute y is equal to 2 in equation 3. Okay, in equation 3. So what I will get is 2x plus y minus z is equal to 5. 2x, 2x plus y minus z is equal to 5. So, so what will I get? I'll get 2x plus 2 minus z is equal to 5. 2x minus z is equal to 3. Now, what we have to do is these two equations. Tell me, what can I do? What can I do? If you see these two equations, what can I do? Can I add these two equations? Can I add these two? Because we have minus z here, we have minus z here, and we have plus z here. Can I add these two equations? So add, step 4 is add the above two equations, right? The above two equations. So what will I get? X plus z is equal to x plus z plus 2x minus z is equal to 4 plus 3, right? Because what is my equation here? X plus z is equal to 4 and 2x minus z equal to 3. So if you see, this z and this minus z gets cancelled out. So what I will be left is 3x is equal to 7. What is x? 7 by 3. Do you all agree? Do you all agree? X is 7 by 3. Do you all agree with this? Now if you see, I have gotten my value of y. I have gotten my value of x. Can I get the value of z? Can I get the value of z? Yes. So what I'll do is, step 5 is, substitute the value of x and y in first equation. So what was our first equation? It was x plus y plus z is equal to 6. If you all see, this was our first equation. X plus y plus z is equal to 6. So what I will do is, we know the value of x is what? 7 by 3, right? So we have 7 by 3. Value of y is 2 plus z is equal to 6. So z is equal to 6 minus 2 minus 7 by 3. So 6 minus 2 is what? 4 minus 7 by 3. So what I can do is, I can take, the denominator common. So this will give me what? 12 minus 7, which is 5 by 3. So z is what? 5 by 3. So now what is our solution for this linear equations? The solution is x is equal to 7 by 3, y is equal to 2, z is equal to 5 by 3. This is what is the solution for our linear equation. Please tell me, is this clear? So basically, if you see, what you said, all of you said, this is also correct. If you add these two, what will be left is, what all of you said is, can you add these two, right? So minus y plus y will get cancelled out, minus z plus z will get cancelled out. So what will be left is 3x plus 7. 3x is equal to 7. So 3x is equal to 7, x will be what? 7 by 3, which is what we got here, right? And now what we'll do is, once we have gotten x equal to 7 by 3, we can put into this equation and in this equation, or any two equations basically. So once we put in any two equations, we'll have two equations which has dependencies of y and z, right? Which has dependencies of y and z. And then because we have two equations and two unknown, we can easily solve it, right? Do you all agree? Please tell me, do you all agree? Okay, perfect. So this was the elimination method. This was what we say as elimination method. Please tell me, is this clear? What we are trying to essentially do? We are trying to eliminate one variable at a time and basically find the other variables. So this is what we say as the elimination method, okay? Now let's look at the graphical method. Okay, let's look at the graphical method. Is Are there any doubts? Please feel free to ask. Are there any doubts? Are there any doubts? Please say yes or no. Okay, thank you. So now graphical method, as the name suggests. Oh, what value did you get for z? Z is 5 by 3. Z is, so what we are doing is, we are substituting the value of x and y in this equation, right? So we have substituted the value of x and y in this equation. and essentially solved it for z. Okay, so the question I see is, what do you think is the most efficient option for solving? Um, and when you say efficiency, because see, we are dealing with two equations, three equations, but what if you have millions of equations? What will you do? Do you think this substitution method would be good for millions of equations? Or do you think this elimination method is good for millions of equations? So that's where we'll learn about this matrix method. That's where we'll learn about this matrix method, which is the most optimal method. If by any chance, if what happens is in engineering, what happens is we are actually taught this programming language called MATLAB. In the MATLAB, we can easily solve any linear equations, and what essentially they use is these methods, this the matrix method, which we'll also deep dive it too. Okay, don't worry, we'll deep dive into these methods. But see, as I said, we are starting from very scratch. That's why it's very important to cover the scratch, from you cover the beginning part of it. Now, what do you think is a graphical method? As the name suggests, something to do with graphs, right? Something to do with graphs. So let me write two equations. Okay. Let's say we'll take the same thing, 2x, our same example, 2x minus y is what? 0. And minus x plus 2y is equal to 3. So what I will do is, I'll create a table. Okay. What I will do is, I'll create a table of x and y. Okay. I'll create a table of x and y. Okay. So let's take this first equation. 2x minus y is equal to 0. So can I write this as y is equal to 2x? Can I write this? Please tell me. Can I write this y is equal to 2x? So our first equation, which is 2x minus y is 0, can I write y is equal to 2x, right? So now just tell me, if x is 1, what is y? Y is 2. If x is 2, what is y? It is 4. Or okay, let me start with 0 first. If x is 0, or if x, okay, let me do one thing. If x is negative 2, what will be my y? Negative 4. If x is negative 1, what will be my y? Negative 2. If x is 0, y is 0. If x is 1, y is 2. If x is 2, y is 4. Do you all agree? Do you all agree with this table? Please write yes or no. Okay, perfect. Now, my second equation. What is my second equation? Minus x plus 2y is equal to 3. So 2y is equal to 3 plus x. And what is y? 3 plus x by 2. Okay. 3 plus x by 2. Or what I can write in other ways, y is nothing but x plus 3 by 2. It's the same thing. X plus 3 by 2. Now tell me okay, tell me one thing. So let's take certain values of x and y both. Okay, let's take certain values of x and y both. When x is minus 2, what is y? When x is minus 2, what is y? Okay, or let me do one thing, to make things easy, I'll take minus 1. So when x is minus 1, what is y? Please tell me. When x is minus 1, what is y? Y is 1, right? When x is 0, what is y? It is 1.5. When x is 1, what is y? It is 2, right? So and so on. We can build this table and so on. So what I will do is, let me build a graph for this. So we all know this is our x-axis, this is our y-axis, this is our negative x-axis, this is my negative y-axis. So basically, if you see, 2x minus 2x minus y is equal to 0. If I plot all these points, it will become a straight line. This will be a straight line. Okay, if I plot this, it passes from 0, 0. We have 1, here we have 2, you know. Then if you see here we have 2, here we'll have 4, and so on. So this actually, this will be a straight line. Okay, this will be what? This will be a straight line. So, let's say this is 1, and so we have drawn this first equation. Sorry, first, let's say this is our equation first. Okay, if we have, you know, and so on. Let's say if we have -1 here, we'll have, -2 here, right? We'll have -2 here, and so on, right? So once we have -1, here we have -2. Now, this is our first equation. Now let's do what? Let's draw our second equation. Okay, let's draw what? Let's draw our second equation. So let's try to draw this, which is minus x plus 2y is equal to 3. So if you see 1 by 2, basically it definitely, 1 by 2 is a common point. If you see, okay, my bad, this 1 by 2, this is what? This is nothing but, this point is nothing but 1 by 2, right? So, okay, we have one point which is 1 by 2. Then when x is 0, when x is 0, when x is 0, what is the value of y? It is 1.5. Okay. And when x is -1, it is what? 1 here, right? It is, okay, let me draw better. Okay, so when, let's say, okay, tell me one thing. When in this equation, when y is 0, what will be the value of x? When y is 0, what is the value of x? -3. When y is 0 here, when y is 0, what is the value of x? Please tell. -3. Do you all agree? So when y is 0, point will be -3 here. So essentially, if you look at this line, this will pass from here. This will pass from here. Okay, this will pass from these points. So this is what? -3 comma 0. This is what? uh okay, this is 0 0 by 1, 0 comma 1.5, and this is what? 1 by 2. So if you see, where are the lines intersecting? The lines are intersecting at this point, which is 1 comma 2, which is when x is 1 and y is 2, and this is basically the solution. When two lines intersect, the intersection point is called what? Solution. The intersection point is what? It's the solution. So where is it intersecting? At 1 comma 2. See, eventually, if you look at the tables also, you will eventually understand that, okay, these are the common points, which means definitely this will coincide at these points. Do you all agree or not? Do you all agree or not? So it's something like this, okay? It's something like this. So this is our first line. This is our first line, okay? And this is our second line. So wherever these lines coincide or wherever these lines intersect, that point is called the solution point. That point is called the solution point. So where are these lines intersecting? At this point. What is this point? 1, x is 1 and y is 2. And this is what is our solution. Please tell me, did you all understand this? Please tell me, did you all understand, or do you want me to again explain this? See, eventually, to be very honest with you, no one uses the graphical method. But again, it's my responsibility to at least tell you what is this method, right? What is this method? It's my duty. What you eventually have to do is you have to take bunch of values of x and y's and then draw the lines, okay? Draw the lines and see where these lines are intersecting. So I'll just write the steps so that, if in case you want to. So the first step is take bunch of x values and calculate what? Y value. This is for both equation 1 and 2. Okay. Then draw both the lines. Draw both the lines. If the lines intersect, if the lines intersect, that means what? The intersection point is the solution. The intersection point is what? It is the solution. And if let's say if the lines do not intersect, if the lines do not intersect, then what will happen? There is no solution. There is no solution for the linear equations. Okay, if the lines are not intersecting, it means there is no solution. And if the lines are intersecting, the intersection point is called the solution. Now just imagine. Okay, this was still easy. Let's take an example. Let's take one more example, which is, let's say 2x plus y plus z is equal to 5. 4x minus y is equal to minus 2. Minus 2x plus 7y plus 2z is equal to 9. Now, see, when you have only two variables, x and y, you create a line. But when you have three variables, you create a plane. Okay, you create a plane. So essentially, what we will do is, this is our x-axis. Let's say this is our y-axis and this is our z-axis. Okay. So what we will do is we will plot. So this is one plane. Okay. This will be one plane. This will be second plane and this will be third plane. So what I can draw is, let's say, I'm just saying, okay. Let's say this is my first plane. Okay. Then let's say this is my second plane. Okay. And let's say this is my third plane. Assuming, okay. Assuming, let's say these are my planes and we somehow get some intersection point. So this intersection point will be called what? The solution for x, y, z. Okay. This intersection point will be called solution for x, y, z. But tell me one thing. Is this a good method from your side? What do you think? Is this a good method? The answer is no, because right now we just have three equations. What if we have, let's say what we have 10 equations, or what if we have 20 equations? This becomes so tough, right? This becomes so tough. That's why it's not easy to, do this graphical method. Okay. So what I'll do is, let me write the limitations, or why people do not use this method, why graphical method is not considered. I'll There are a bunch of reasons. Okay. See, first of all, this geometric visualizations work for two or three variables. But if let's say there are higher dimensions, visually we cannot understand this. Okay. Because let's say if you have four dimensions, we actually cannot draw this. Visually we cannot draw this. So what I'll write is geometric visualization only works for two or three variables. Okay. Only work for two or three variable. But higher dimension, let's say for higher dimension, let's say 10 variables or more variables, right, this method cannot be visualized. This method cannot be visualized. Second is lack of precision. Lack of precision. What does that mean? See, when you draw lines or when you draw planes, right, it is not possible to accurately find the solution. Like let's say x equal to 2 by 3 and y equal to 7 by 3, it is not possible to look into the graphical structure, right? It is not possible to look into the graphs and see, okay, what is the value of x and y. So to identify exact points of intersection is kind of difficult, okay? Identifying the values of x and y with precision is very difficult, okay? And that's why we do not use the graphical method, okay? That's why you do not use the graphical method. Is this clear? Please tell me, is this clear? Did you all understand the three methods? The the substitution method, the elimination method, and the graphical method. Did you all understand? Okay. So now what I'll do is I'll just okay. Yeah, so I see a very good question. Does this connect to vectors and further way to solve vectors to matrices? The answer is yes. Okay, so that's a very good question. And the reason, if you see, the reason I'm teaching, okay, let me share my screen quickly. Just give me 1 second. Okay, okay, can you all see my screen, basically? Okay, let me do one thing. So what I will do is, if you look at this book, that's a very good question, that are we understanding the vectors after that? Yes. See, if you see the book starts with this, the book starts with this, basically. Okay. So it starts with this understanding of this. Okay, this is our first, which is the first chapter is matrices and Gaussian elimination. Basically, it basically walks through this, the concept of line, the concept of plane, and how can we use, basically how can we solve the equations. How can we see, if you see the elimination method, right? The cost of elimination method, bunch of these. So essentially what I'm trying to do is I'm just trying to cover this book bit by bit. Okay, so first we'll understand matrices and then we'll understand vector space. So what I'll do is I'll stop this recording and I'll start a new recording so that this class does not get a really long, so that if anyone who misses the class can rewatch the class. So let me stop this recording and start a new one.